Second semester and we're back. All right, today is the first YouTube notes over second semester material for Academic Algebra 2. Now, we're going to be talking about how to break down different roots with a different index. Now, just a reminder of vocab. The index is the number sitting on the outside of the radical. The expression on the inside of a radical is the radicand. So, first off, let's go with some review. Notice there's no index here. When there's no index, it's assumed to be the square root. So that's how we're going to treat it. To find the square root of 24. Now, it's not a perfect square, so I break down into the factor tree. Doesn't matter what you start with, but you go all the way down to primes. We've all done this before, but just reviewing some skills that we're going to be using on the next few. The index is 2, so that means for every pair of a number, it's allowed to come on the outside. So we have a pair of 2s, so the 2 is allowed on the outside. There's no pair with the 3 and the 2, so that stays on the inside, remaining 6. Now I did that quickly because that is 100% understood, or should be at this point. Now, all of a sudden they throw us an index of 3. I refer to this as the doorman. It's like a doorman at a club, okay? Hey, you're only allowed out if you have 3 people in your group. All right, let's break it down the exact same way and see if we have any triples. 54, I'm gonna go with 9 and 6. That's 3 and 3. That's 2 and 3. Same skill. But now I'm looking for 3 of a number instead of just 2. Well, if you'll notice, I have 3 3s. So that doorman's allowing me to come out with a 3 because there were 3 of them. There's only a single 2. That has to stay inside. Don't forget, in your final answer, you have to write the index that you started with. All right, now, variables. Variables are treated the same way. If I have an x to the 6th, that's 6 x's. That's 6 x's. Now, I'm only going to do this once, and then we'll show the cheat. So if I were to write it out, that's 1, 2, 3, 4, 5, 6 x's. Well, the doorman, the index, says I'm looking for 3 of something. Well, there's a triple, so a single x is allowed to come out. There's another triple, so another x. So 2 x's are allowed to come out, making it an x squared. Notice there's no x's left over, so none would go back inside. Y to the 7th. Again, this is the only time I'm going to do it, then we're going to discuss a little cheat. 1, 2, 3, 4, 5, 6, 7. Now, you realize this is really going to be annoying. And if you're looking ahead, was he to the 27th? No, I don't have to write that 27 times. So we're going to discuss what we can do to make it a little faster. Again, I'm looking for triples. 1, 2 triples, and there's 1 left over, which means 2 y's would come out, and 1 would be left over. Now that's my final answer. But how can we address those variables much faster? Old school division. I'm talking 3rd grade. You remember remainders? Yeah, they were wonderful. Remainders. Take the exponent on the inside, the radicand exponent divided by the index. Think of it this way, the x. It would have been 6 divided by 3, which is 2, remainder 0. What's up? Take the y. 7 divided by 3. 2, remainder 1. Hello. Right? Let's use it. Let's put it all together now. My doorman here is 4, which means I have to have 4 of a number in order for it to come out. Okay? So, starting with 80. Let's go 8 and 10. I got 2 and 4, 2 and 2. Make sure we don't confuse these problems. 10, 5 and 2. Okay, there's my prime factor tree. Look for 4 of a number. 1, 2, 3, 4 2s. I'm allowed to pull that 2 out then. There's only a single 5. Remember, end of the roots. End of the roots. The only thing left is a 5. So I put 4th root, and I know 5 is going to be left in there. Okay, instead of writing it out, let's use our little fast cheat. For the x, it's going to be 13 divided by 4. Notice inside exponent divided by index. 4 goes into 13 3 times with 1 remaining. So that means x will have an exponent of 3 on the outside with a single x remaining inside. Isn't that nice and fast? It goes quick. Y. 5 divided by 4. That's 1 remainder 1. So one way on the outside, one way on the inside. Last one. This is where we're really happy that we don't have to write it out. I don't have to write 27 z's. 27 divided by 4. 4 goes into 27 6 times with 3 remaining. So I put a z to the 6, z to the 3rd on the inside. It's a quick tutorial on how to break down nth roots, any radical with an index of any number. All right, hope it helped.